Hey there, Mr. Weaver here, and this is topic 9, lesson 2, solving quadratic equations by factoring. After this lesson, you need to be able to solve for the x or variable in quadratic equations by factoring. You'll know you're successful after this lesson if you can factor a quadratic equation to reveal the binomial factors, and use the zero product property and set each binomial equal to 0, then solve to reveal the solutions. This is the second method that we are looking at to solve for our variable in a quadratic equation. So factoring is the second method. Here's how to do it. First, if you need to, rewrite the equation in the form y equals ax squared plus bx plus c. So you're just rewriting it into standard form. Then you're going to factor the polynomial. Somewhere in those first two steps, you're also going to need to make y equal to 0. So you'll have 0 equals your expression. Then, after it's set equal to 0 and you factored it, you're going to use the zero product property, which says that if a times b equals 0, then either a or b must be equal to 0. In terms of what we are doing, if we know the two factors are equal to 0, then one of those two factors has to be equal to 0. So if we set them equal to 0, then we can solve. And that's our last step, is solving each new equation for x. Let's look at our first example of how factoring works to solve our equations. So here we have x squared plus 3x minus 10 equals 0. It's already written in the form y equals ax squared plus bx plus c, except our y value is on the other side. And they've already set it equal to 0 for us. If it was a y still, we would change that to a 0. So since it's in the format we want, our next step is to factor our expression. So if you think back to topic 7, there were multiple lessons on factoring. If you don't remember how to factor, you might want to revisit topic 7, lessons 4 and 5, and maybe 6. When we're factoring, you're going to multiply to what a times c is, and then add to b. Here, since a is equal to 1, we're really just going to multiply to c, which means we're going to multiply to negative 10 and add to 3. You need to figure out what two factors multiply to negative 10 but add to 3. We could figure out that those numbers are positive 5 and negative 2. Now that I know those factors, since this is a simple factoring case, meaning that a is equal to 1, we can just take those two factors and plug them in with x. So I would have x plus 5 times x minus 2. Now that I have factored, the next part of this is to use that zero product property and set each of them equal to 0. So I'm going to set x plus 5 equal to 0 and x minus 2 equal to 0. Now we're going to solve each new equation. So x plus 5 equals 0, I would just subtract 5 from both sides, so x must be negative 5. For x minus 2 equals 0, I would add 2 to both sides, and I would get x equals positive 2. Those are the two zeros or solutions to this quadratic equation. If you plug in negative 5 in for x, it comes out to be equal to 0. If you plug in 2 for x into your original equation, it comes out equal to 0. We could also check with Desmos typing in our original function and see, does the graph cross the x-axis at negative 5 and positive 2? Yes, it does. So those are our zeros. Now it's your turn. Pause the video. Figure out the zeros of this quadratic equation by factoring. Let's check. You should have got x equals -6 and x equals -7. Here's how to get that. We start with our original equation. It's already written how we need it. If we factor, they would multiply to 42, but add to 13, which gives us factors of +6 and +7. So x plus 6 times x plus 7 is equal to 0, meaning that either x plus 6 equals 0 or x plus 7 equals 0. So you would subtract 6 and get -6, or subtract 7 and get -7. Those are your two zeros. In our next example, it doesn't necessarily look like it's in the right format. However, it is just missing a c value. We have 5x squared plus 15x and no c. So c is equal to 0. For this one, we're going to look at a slightly different way. If we take our original equation, one thing you need to look for is if you can take out the greatest common factor. So if you can, you might want to do that first. So in this, I can factor out a 5x. And if I do that, 5x squared divided by 5x leaves me with an x, and 15x divided by 5x leaves me with 3. So factoring it out, I have 5x out front and x plus 3 in parentheses. Sometimes this is all you need to do to factor. From here, the steps are the same. I'm going to set each factor equal to 0. So 5x equals 0 and x plus 3 equals 0. Which means in the first equation, if we divide by 5, x is 0. 0 divided by anything is 0. And x plus 3 equals 0, we would subtract 3 from both sides. X must be -3. So our zeros, or our solutions for this equation, are 0 and -3. Now it's your turn again. Pause the video and factor this quadratic to find the zeros. Let's check. You should have got 0 and -8. So if we start with our original equation, factoring out the GCF would be 3x out front, and x plus 8 is what's left. Setting them equal to 0, 3x equals 0, so x must be equal to 0, and x plus 8 equals 0, so x must be equal to -8. Let's look at one last example for factoring. So here we have 2x squared plus 11x equals -5. The way that it is written right now, it is not in standard form. We have that -5 on the wrong side of the equation. So we need to add 5 to both sides. That way we can get rid of it off the right, and now it will be on the left side. When we do that, it's automatically set to 0. -5 plus 5 equals 0. And on the left side now we have 2x squared plus 11x plus 5. So now we have our proper format. We can factor. So I'm going to factor. We need to multiply to a times c and add to b. So a times c of our rearranged equation is 2 times 5, which is 10. And then they need to add to 11. So what values multiply to 10 but add to 11? We find those two values are +10 and +1. Now, this is where factoring might not be as easy as other methods that you'll see later, but it still works. So when a, that first number, is not 1, factoring is a little more complicated. So when a is not 1, you need to make some boxes, fill them in, and then your factors are your GCFs on the outside. And for more detailed explanation of how to do this, look back at Topic 7, Lesson 5. So we're going to fill in the first value and last value in the top left and bottom right. And then we're going to take our two factors, 10 and 1, put them with an X, and fill in the other two boxes. Then we're going to take the GCF of each row and each column. So in the top row on the left, we would have X, and in the bottom, we would have plus 5. Those are the greatest common factors of our rows. And for our columns, we'd end up with 2X and plus 1. Those values on the sides are your factors. So that's what we're going to use. Now we're going to set each equal to 0. So 2x plus 1 equals 0, and x plus 5 equals 0, and then solve for each. So let's start with 2x plus 1 equals 0. To solve for x here, I would need to subtract 1 from both sides, and then divide by 2. So we would find x equals negative 1/2 or negative 0.5. For the other one, I would just need to subtract 5 from both sides, and we're left with x equals negative 5. So those are our two zeros, negative 0.5 and negative 5. Again, you can check with Desmos to see when you graph it, are those the places where the parabola crosses the x-axis? Now it's your turn one last time. Pause the video and factor this quadratic to reveal the zeros. Let's check. You should have got x equals negative 8 and x equals negative 2. Here's how we get that. First, add 16 to both sides. That way we get it in the format we need. Then they multiply to 16 but add to 10, so your values must be 8 and 2. It was a simple equation for this one, so we can just use our values. We didn't have to do the box, but you could have if you chose to. You end up with x plus 8 times x plus 2. Setting each equal to 0, our final answers would be negative 8 and negative 2. In this lesson, we learned about solving a quadratic by factoring. And this involves approximately 3 steps. First, set the expression equal to 0 if it's not already. If it's equal to something other than 0, then add or subtract that value from both sides until it's equal to 0. Next, factor the expression to find the two binomial factors of the expression. So for example, if we had y equals x squared plus 5x plus 6, we would make it equal to 0, so change y to 0, and get 0 equals x squared plus 5x plus 6. Then we would factor our expression to get 0 equals x plus 2 times x plus 3. Finally, we use our zero product property, which states that if the expression equals 0, then at least one of the factors must be 0. So using that, we can set the binomial factors equal to 0 and solve. So in our example, we would do x plus 2, one of the factors, equal to 0. Solve that and get x equals negative 2. And x plus 3 equals 0. So solving that, we'd get x equals negative 3. That means that our solutions, or zeros, for the equation are negative 2 and negative 3. And we can check those with Desmos by graphing and seeing if those are the places where our parabola crosses the x-axis. After this lesson, do you now know how to factor a quadratic equation to reveal the binomial factors? And do you know how to set each binomial factor equal to 0 and solve to reveal the solutions? If you're not comfortable with factoring in general, go back to topic 7, lessons 4, 5, and probably 6. If you're just confused on this concept of solving, then rewatch some of the examples. And that's the end of lesson 2 on solving quadratic equations by factoring.